How does the velocity of water affect the length of fully submerged plants in a stream? The independent variable was the velocity of the stream, and the dependent variable was the length of the plant.
Maria, Ghazal, Fiona, Gitta, J, Jakub, Dan.
What you need is measuring tape, meter stick, GPS device, stopwatch, boots, more boots, and an orange.
We first used the measuring tape to measure 5 meters of the stream, marking point A and point B. We timed how long it took for the orange to float from point A to point B. We then did this for 10 areas, with 5 trials for each area. We measured the length of the longest plant that was found in each chosen area.
Area 1 was very shallow with many rocks. It was also quite narrow. The measured velocity was 0.5 meters per second squared. The maximum algae length was 48.5 centimeters. Area 2 was very deep, slow, and wide. There were no rocks above the surface. The calculated velocity was 0.33 meters per second squared. The max algae length was 83 centimeters. Area 3 was very narrow and shallow. The calculated velocity was 0.46 meters per second squared. The max algae length was 55 centimeters. Area 4 was very deep and wide. The current going slow and there were no rocks present on the surface. The velocity of the water was 0.23 meters per second squared. The max algae length was 39 centimeters. Area 5 was deep and wide. The current was slow and there were no rocks present on the surface. The calculated velocity was 0.25 meters second squared, and the max algae length was 73 centimeters.
Area 6 was narrow and shallow. The current was going fast and there were no rocks present on the surface. The calculated velocity was 0.46 meters squared per second squared. The maximum algae length was 51 centimeters. Area 7 was wide and deep. The current was slow and the calculated velocity was 0.33 meters per second squared, and the maximum algae length was 81 centimeters. Area 8 was very wide and deep. The current was medium. The calculated velocity was 0.40 meters per second squared, and the maximum algae length was 94 centimeters. Area 9 was shallow but wide. The current was quite fast. The calculated velocity was 0.46 meters per second squared, and the maximum algae length was 97 centimeters. Area 10 was very narrow with many rocks. The current was going fast. The calculated velocity was 0.58 meters per second squared, and the maximum algae length was 57 centimeters.
Now, upon closer inspection, we actually discovered that what we were measuring was in fact algae, not plants, so we had to change our research question to...
How does the velocity of water affect the length of algae formations, which changes the dependent variable to algae length?
This is the raw data table with the calculated values to the right, and this is the graph plotting water velocity and algae length.
To some extent, the results show a correlation between water velocity and algae formation length. However, other data points do not show any correlation between the two variables. A fast current would generally mean longer strings of algae. There are a few variables that could have influenced our data. First, wind affected the surface velocity, and surface velocity may be different than the velocity underwater. Second, the depth of the stream at different points was not considered. And finally, the curves in the stream created more difficult setting for the orange to float smoothly. This delayed the speed of the orange.
I came in like a wreck.